Hi, we are going to explain the n-queen problem and the algorithm to solve this problem. First of all, we know how the queen works on the chessboard. If we put our queen here, these are the cells it can go. So we must put our second queen in a way that do not cross these cells. So we have to put this here. We cannot put this here, it's diagonal. We have to put this here or here. So these are only options we can put our queens. So we have to create an algorithm to place our queens in that way. That's the problem. Now, we first start with 4 queens. That's the simplest approach. And whenever we're using our code, we are creating an array that represents the board. So our array has 4 index. It's a 4 size array. For the number of queens, for example, we have 4 queens here, so our array must be in 4 size. And each index of this array represents the row on our board. And the data we put in that index of that array represents the column in which the queen was placed. For example, if we have an array that has index of 2, the second index of that array, the data is 3. Let me put English to here. So yeah, our index is 2, data is 3. That means on the second row, on the third column, we placed a queen. That's the way we are going to represent. So here, which will be the result of our algorithm, we figured that in the first index of our array, on the second column, we put a queen, and on the second index, it means the second row, on the fourth column, we put another queen. This third index, the first column, and the fourth index, the third column. That will be the result of our code. Now, in our code, we first must see in what condition we cannot put our queen. That's these conditions. First of all, when we are going to see if that cell is promising, if it's on the first row, it's always promising. I'll explain that later. And the second condition is, for example, we have a queen already placed in here, and we are on the second row to see if we can place our queen or not. We want to see if this first index we can put our queen or not. You see their column, the second row column is 1, and and the queen on the first row, its column is 2. These are not equal, so we pass this check. But here it checks if they are diagonal, so we want to put our queen here. The number for the row is 2. See, the number is 2. And our queen number, the one that already occupied, is 2. Now, excuse me, it's 1, the row. The row is 1. The row for the candidate is 2. Now the column for our candidate is 1. Place it here, and the column for our previously placed queen is 2. Now if we subtract this, we ignore the negative. If we subtract this, you see we have 1 equal 1. So this checks true, this is diagonal, and we cannot put our queen in here. The same goes for this. The columns are equal. Our candidate column is 1, and the index of already previously placed queen, its column is 2. They are equal, and we cannot place our queen here. So these conditions, if any of them is met, we cannot put our queen in that place. Now, before I start the code, I'm gonna tell you how the code acts. First, it will place the queen in here. Because it's the first row, it has no problem. Then it goes to the second row and check if it can put the queen in here or not. It goes to this condition and finds that their columns are equal. So you cannot put the queen in here. Then it goes to the second column, and it's not the first row, the second column. The column number is 2, and our queen, its column is 1. It gets, though there's no problem here as well, but when it comes here, the first row, here the row 1 is 2, and row 2, our queen row, is 1, and our column or candidate is 2. The column for our queen is 1. These are equal, and it can put the queen here as well. Cannot put it here. So it goes to this cell and check if it can place the queen here. All these conditions, none of them is met, so it can't place the queen in here. When it places the queen in here, it calls again and goes to the third row, and it starts from here. It goes to this condition and it finds that the column is equal, so it cannot put here, and it goes here to see if it can put it here. Now, one thing I missed to tell you that these conditions are called from the first row. So when our code reaches here, it starts calling this condition from the first row. The columns of the queens that are placed here, and it goes right on this until this second row. And at first it checks for this first row and then check for the second row. So when our code reaches here, it first check if the queen on our first row is the same column. It is not, and it goes to the second row and it checks if the queen in this row is the same column. It is not, but goes to this one and find that it is a diagonal, so this one also get false, and it cannot place our queen in here. It goes here and then finds that the column are equal. It cannot put it here. It goes here and find that it is diagonal. It cannot put it here, and ends up going back. Our code goes back one row up. It did not find any place here to put our queen. It goes up. When it goes up, the thing that happened here is it places the queen here, and the queen in this place get erased, and it starts from the next row and compare. It starts from here and compare from this queen and this queen. It goes here and see it cannot put it because of this queen. Place it here, sees it's not same with this queen, and then goes to the second row and sees that has no problem with this queen as well. So it establishes this queen in here and realize there is no problem, and then start that queen, start the process, and on the next row it goes here and see that this is diagonal with this queen. It places here and sees that it is the same column from this queen. It places here and sees it is diagonal with this queen, and it places here and sees that this is the same column from this queen when it was approaching this way up until this cell. So it sees that this whole row, it could not put the coin in here, and it goes back to this row and places the queen in here and erase that one queen in there. And because of that, again, when you put the queen here, it sees that this is diagonal with this queen, so it has to remove this queen. and change the place in here. It places the queen in here and sees that this is the same column. So it sees that you cannot place the queen in here because of this queen, and it goes here. It goes here and it sees that this is the end of the line, end of that for loop. It cannot place the queen, and the for loop is finished. So it goes back, it goes up and reaches this place and increments the index to another one and goes to the next row, next column for that row, and again starts checking from the first column of this second row. This is diagonal, this is the same column, again diagonal, and ends up placing it here, and goes here and it sees not the same column and not diagonal, so it puts it here, and then goes the next row, cannot put it here, it cannot put it here, diagonal with this and also this, and it comes here and see it can put it here, so it put the column here. When it does that, it goes to the next column and see if it can remove this and put it here. It goes to this condition and see it is false, it cannot put it here, and then it reaches the end of the line, end of the for loop, and because of that it goes to the out of bound index. That means the next row, this is the fifth row, when it is going to start the whole queen method here, we check if our row is n plus 1, n plus 1. It means we reached here in our code. So our column, our array is complete. It has all the data we needed. So we extract this array, we print it, we put it somewhere, we reach the result. This is the first result. This is it, the first result. Now, what happens here is it reaches here, we print the first result, and we start over from. That means we return early and go back here to the first row. That means here we go here. Now we've reached here, and this condition is met. This is our first row, so we do not check for this or this. This is our first row, and when we reach here, we put the column in this array. So now the array is overwritten. What was previously 2 now becomes 3 for the first index. So it gets removed, overwritten. Now our third index, third column has a queen in it. And then from here we go to the next row. Start from first index. We put the column, the queen in here, the candidate in here, and our code always starts these checks, these two checks, from the first row, top to bottom, until here, not here, up until here. So our check is only from the first row. Now, first row, the column is empty, and also the diagonal is also empty. It can't put a candidate in here, so it puts it in here. That overwrites our previous data, which was 4. That means the 4 in here was overwritten by 1 in our array. Now the second index have 1 instead of 4, and then it goes to the next row. It places the queen in here, and it sees and it checks from top to bottom. It checks from the first row with this queen and sees that it is diagonal, so it gets a false, and it cannot put it here. It goes to this place, check from above, no problem here, but problem here, it is diagonal, so no. The third column, again it checks from here, same column, cannot put it here, and the fourth column it can. Now it goes to the next row and it starts from here. Here, same column, here, nothing, no problem. So it puts the queen in here, which overwrites the queen on the third. So when it reaches here, our code continues. It also checks this place, so it checks this place. I'm sorry, not right now. When our code put the queen in here, it goes to the next row, which is the out of bound and +1 row. At this point, it prints the result. It gives us the result, which is this. After giving us the result, it continues to the next cell. Sees this is the same column, next cell, same column, and returns. Continues the process. It goes from above and continue the result and see that only 2 of these can be used. So here's the code. Now I explain the code after 25 minutes. That's a long time. Now the code here, what does it do? This is the place where we print our results. This will print these 2 results. This is the check for n+1. This is the place we check for n+1. And here before loop for the number of columns we have. So we have 4 columns here. We call this for loop 4 times. That means we call this 1, 2, 3, and 4 times each. And if we can place the queen here, for example here, if we can place the queen in here, we call the whole queen method again. But before that, we place our answer into that position, the array position. So here we put 3 on the first row, and then we call the queen. Going here is calling the queen method. So this queen method gets called, and the current row here is incremented. So the current row becomes 2. So let's continue and see. Here, this debugger is using the first. So the first answer is 2, 4, 1, and 3. Now we call the method with this, with queen's first row. This is a one index based index or whatever. That means we have 4 capacity for our array, but here n+1 means when we reach the 4th column, the n must be 5 here when we have 4 queen. The n being 5 is the index we want to print our result. That we choosing the one index space resulted in our 4 loops start with column 1 instead of 0 in here, and also the equal here. The same in this place. The previous row is 1 because of our choice in one based index. Now after all, we called the queen method with first row in mind. Our queen method started. This is the first row, so we skip this and we come here and we call this 4 times. If it is promising, we place the queen in that cell and then we call the whole method again. It goes recursive and goes inside the queen with one incremented row, the next row. So now we are here and you want to see if it's promising. First column, first row. We come here and this is the our current row is 1. This is the first row. This condition. So we return true. This is promising. and we place the column inside that array, and we call the whole method again with the next row. Now this is the second row. We come here, we call for the second row. For the second row, we call 4 times in this for loop. This is called, each one of these are called one. If promising, if true, place the queen, and call the queen method, which goes to the next row. Now the for column, the for method, for loop is called. This is the first column. Is it promising? Let's see. The first column is diagonal with the queen we have. So this is what's going to happen. Our existing column, which is this column, is 1, and attempted column also is 1. So we are checking. Let's see, our array, our first, this is the approach that fails. So this is not this approach that is going to give us answer. This is the first approach where the queen is placed here, and yes, the queen is placed here. Existing column means the chosen queen column for the first row, and the attempted column is this one, where we are going to see if this is promising. These are equal, so it's going to give us false. It gives us false. This is false, and it goes for the next column, which is here, and it will check. This is not the same column, but this is diagonal, so it goes. This is not the column, not the first row, and it starts from the first row. Our for loop, our promising method, is a for loop that goes from top to bottom here, up until the row, up until here. So for example, if we are here, this for loop starts from top up until this place. Check this row and this row and this row, and see if any of the placed queens is promising or is making problem for our candidate, whether diagonal or in a vertical, horizontal. So it checks for diagonal and it returns false because of the diagonal, and it's false, so it checks the third column. See, the column index is 3. Now our current row is 2. This is the current row, and the column is 3, and checks, and it returns true. it returns true. So this is promising, this is true. It put the column index 3 in that row index 2 of our array. This is our array. This is current row. Ignore -1 because we are using one index space, and we put 3 on the second row. Here, the second row, put 3, and we go for the next row here and start from 0, first column. We call the whole method in a recursive way, but we already increment the current row. It goes here. This is not the last row, and we call promising 4 times because we are here, and we are going to call this on this one and on this 4 times. So we call here, let's see, we cannot place in here, but we cannot place in here, not here, and not here. So all the 4 loops must return false. This is the first time. 4 times this for loop is going to get called, and all of them must return false for promising. Look, it starts from the top row. It starts from here, and then here. Our promising method starts from top to bottom, and it returns false. It returns false again, returns false, and our column is 3. Column becomes 4. This is the last column. The row is from top to bottom. This is false, and the 4 is finished. The for loop is finished, and this queen method is exited. We exit from this method, which was recursive. This current row was 3 here. It was 3. It was 3. Now when we finish from that queen method, we go up. The current row becomes 2 because we did not find anything here. We go up here. See? This is the exit of the queen method. We were here, and then we exited. Now we are here, and our current row is 2, and our column is 3. It means we were here, where we established that this place is a good place to place our queen. Now, since we went there and we didn't find anything, we went back up. We came here, and we go to the next column, because this for loop is incrementing our column. This is 3, and it becomes 4, the 4 column. and it checks if this is promising, if this is promising regarding our column, our established queen in here. And it comes here and it goes and see that this is true. It returns true. It places 4 as the queen chosen column for this row here, and calls queen and goes to the next row. Now current row is 3, and we will check from here to here. We check here and see this is not working. Check here and we find a good place, and we go call the queen again. We check here, we see we cannot put it. We check here, we can't. We check here, we can't, and we check here and see we can't here. Now I'll show you the code. So we are checking here and come is here. And this is promising. As I told you, this was promising. It goes and calls the queen and goes on the 4th row. See, the current row is 4. Now, current row is 4, and it starts to do the 4th column check. None of them is promising. None of them is promising. All of them will return false. This is the first column. The second column also returns false. For the first row, for the second row, it returns false. And we are on the 3rd column. Here also return false. Now the whole thing returned false. We are on the 4th column. It must return false too. It returned false. It's diagonal with the first queen, so it returns false, and we are done with this for loop. With this for loop, we are done. So we did not reach anything. Because of that, we go up to this one and go 1 row again and check with this one, and we'll see this is diagonal. We cannot put in here. We go to the next one and we'll see we are the same column here. I'll show you the code. So now our current row is 3. We went up. We are here, and we are here, and we are on the next column, column 3. We are here, and we see if this is promising. Is it promising? No, this is diagonal with the current, with the this is diagonal with the second row. No, the first row. This is diagonal with the first row. Because our promising loop started from here and it checked comparing to this queen on our first index. And now this is false and our column number is 4 and it is the same column of the second row here. Look, this for loop start from the first row from here and it will check if the queen on the first row, it will compare our candidate with the queen of the first row, and then it increments on the for loop. The next for loop comes here and check our candidate with the queen on the second row. So it goes here. This is the same column. Now the column becomes 5. The for loop is finished. We are here at the end. We are here at the end of the column. And we exit the queen method, which was this recursive. We are going out of this queen method. Here, we already finished. Our current row is 2. We are here. And we are here. And our column is 4. Our column is 4. Now becomes 5. And we reached the end of this second column. We incremented the for loop incremented the column. We became here, so there is no index on here, so this for loop is finished. This for loop is finished and we exit the queen method here with no success. Now our current row is 1. Now we are here. Now we are here and we increment this to the second column because we were in the for loop here. Our column becomes 2 and see if this is promising. We are here and see if this is promising. And our promising, check if we are the first row, it's always promising. So this is current row is the first row. This is true. Why is it true, the first row? Because there is no row above it. We always go from top to bottom. We check with the topper row, above row. There is no row above it. This is the first row. So it's always true. And then is we put the column number into that, and we call the queen method. We go to the next row and we start from here to next, and let's see if we can skip that because we know what's going to happen. I am going to disable these and only stop. Okay, we are on the fourth column of the second row here, and we find our candidate. Now we call the queen. We are on the third row, and we are here. If we start from here, and if we are successful, look, we are on the third row, first column here. We are successful, and we are going to overwrite the column data here. This is overwriting what was previously 4 is now being replaced by 1, and the queen is called afterward. We go to the next. So we are here, current row is 4, and what is the candidate for that? The candidate is here. Let's see. Our column is 3 and our current row is 4. We are here, and this is it. And this is a successful result. After that, we call the queen method. We call in the queen method with current row 5. Current row is 5, 1 above the 4 queen. Now this is the result we wanted. This is the out of bound result. Now we print the result and return from this method. We print the result here and we return, which means we go up. After that, we try to see if this one is candidate. It returns false because of the first row, and then we go to this one. This returns false because of this. This also returns false. We go up here, and because we are here, when we go up, we are at the end of the index. We go one more up. The queen exit. We come here and we increment this, and then we come here. We try this one. First row 3, and the next. The rest is obvious. This 3 has the answer, and this is it. If I skip all of these and come here, we see we have 3 1 4 2 3 1 4 2 for the next iteration. As I explained, we moved from here to up, and we reached here, and we incremented this, and then we started from here again, started here, we found the queen, and we went to the next, and we went to the next row. We reached here, we printed our results, and we continued if we can find anything more, and then we reached the end of the code, and we printed these two results. This is it. This is how the code works. Yes, we declare we have 4 queen, and we created this array with 4 size, and then we call this queen, and then we do the recursive here with this iteration, recursive inside iteration, and we do the promising check, which is all these promising checks, and we all started the whole thing with calling the first row. That's it. Goodbye.